welcome to the Mythruna live stream, where I will do some development on, I think, AI tonight. We're going to be working on some steering behaviors. Going to try to put some little more life into the birds, Gafen. So before we get started, let me go ahead and thank my patrons. Thank you guys. I wish everyone has a happy holidays this season, but especially you guys, you patrons. I especially wish you guys have a happy holiday. Alright, so without too much more preamble, let's go ahead and get started. I'll talk a little bit about sort of what I did this past week. I don't remember what I did the rest of last weekend after we got that visualization working. I do know, I think I might have played with dragging a little more. I do know that one of the things I want to start finalizing soon is the world fractal, and also the way I want to do sort of death and have like a spirit plane and all that other stuff. I realized there was a deficiency in how I store my world data that was going to prevent that from happening, and those are related to core classes in the sim math package, the grid class over there, and how it generates IDs and bit masks and stuff for those. So I had to spend a lot of time writing unit tests to make sure I didn't screw that up when I fixed it. Hopefully you guys can still hear me and I didn't just unplug my microphone. Let me just check. It's still going. Yep, you can still hear me. Okay. So I spent a lot of time doing that, and then I found yesterday I started to implement a teleport. That's what I'm going to show you real quick. A teleport script, and 2 or 3 years ago, someone had reported a bug in my sim ethereal library. I think it was Ali RS is what he goes by on the Discord and stuff. That warping wasn't working. Like if you moved an object too far, it would stop being tracked and stuff. Well, especially if it was your object, because the nature of keeping track of where you are in the world, it only keeps the surrounding stuff loaded and heavily tracks all that. So if you moved too far, that tracking would stop and you wouldn't get any updates. And I spent a good deal of yesterday figuring out why that happened, and then it took about an hour to figure out why, and then several hours to fix it because it was a tricky bug. Previously, if you imagine the world is set up as zones, like if these blocks are different zones, like I'm standing in this one and these blocks are different zones around me, the existing algorithm kind of adds listeners to all these different set zones, and then as I move into the next zone, it drops the listeners from the ones that I'm in and adds new listeners to these. But if you move too far, nothing notified you that you moved, and it didn't even know. So this is kind of a metaphor, right? These obviously the zones that the network can keep track of are really big. But anyway, to try to explain it without having to draw a diagram, because I'm really talking about something else. But so now there's this, and this is temporary. Like real players in a multiplayer game wouldn't be able to do this, but like if I just do it with no arguments, it warps me up into the sky, which used to break. And so then I'll go falling down again. Which is kind of a cool view, especially since the field of view has been tweaked a little bit, so we get a little wider view. There's our spawn tower. The other thing is I added a respawn. So no matter how far away I wander or how far away I teleport, if I respawn, it takes me right back to the spawn tower. Oops. Yeah, I always forget that this thing is... And what that allowed me to do is do cool things like I wanted to see what... Like we're all the way at coordinate, million, whatever, and a million. And I wanted to see what was at 0, 0. So I warp 0, 0. Like... And so it takes me out here, up in the sky. And so this is what's at 0, 0, which is basically ocean. There's a little house on this island. I went here last night, of course. So if I zoom over to here, and least land on the land. So you can see the map over here. It's kind of a cool area of this world. Way farther than we'd ever be able to walk. And anyway, the point is that obviously warping is now working. You can teleport, which is going to be part of a game mechanic later. And when I started exploring, visiting the spirit plane and stuff like that, which is how death will work and some other magic, and portals and things, then I'm going to need to be able to teleport there and back again. And so I needed to get that fixed. And so now it is. And now I can get back to where it was. Whoops. Blink. And now we're back over here. Right into the... Whoops. I always do that. I forget that when you enter a command, it leaves the chat bar open because it assumes you're going to want to chat again, whereas if you're just chatting, it closes it. So anyway, let's scooch back over here because this is where we're going to have our little playground for playing with Gafen. And I've even given them a little pin over here for wandering around in. And so now as we give them some behaviors, we'll be able to see how they interact with one another and the environment and so on. One of the first behaviors I'm going to give them, right now they just do the random wander, and I'll probably just make a rudimentary brain that will switch them off between the different steering behaviors I'm going to test. So they'll continue to do the wander, maybe wander for 3 seconds, and then do something else for 3 seconds, and then do something else for 3 seconds. Initially, probably just run them in sequence. I also want to play with selecting the animation so that I can make them stop and play the eat animation. So let's go ahead and get started with that. Make a little brain and anyway. So I don't know if anybody's ever been able to join. Currently, no. So it might just be me tonight. If there's time, I want to talk about map generation because that's going to be where I'm focusing a lot of time on over this next week, I think. It's one of those big areas that I still have to make some large moving pieces before I can do the endless tweaking that I can do, 2 hours, 3 hours at a time. All right. So we've got the AgentDriver. Its rough organization is that every update, it calculates collision data based on all the contacts it's gotten, and that's how it knows it's on the ground or running into something. And what's step? Oh yeah. So if step is how much time has passed since the last time update was called, and if that's greater than 0, then we calculate the actual velocity based on how far the rigid body has moved. And so obviously, if step was 0, we can't do that because actual velocity is this divided by step. Actual velocity being in meters per second kind of thing. And so once we know what the actual velocity is, we can come down here and calculate our steering. Once we've calculated the steering, there's a contact avoidance steering, which uses the the probe movement input, where we do probe to see what's there, and avoid it if possible. Or no, this is near contact, so that we collected. Yeah, okay, so this is just if we've collected nearby contacts and we're editing the probe movement input. So probe movement input is a vector that says whether it's moving forward or sideways or up and down. And steering will fill that in. So we have regular movement input. So kind of like if the agent was hitting keys on a keyboard, right? They hit forward, back, left, right, up, down. And we keep a separate one, which is based on, for collision avoidance. That's the probe movement input. The first one we do is based on the near contacts, which is, when we're actually running into walls and things, we want to turn away from them, not just with the probe. And so we check all that, do some adjustment for things that are, what is this? Yeah, so we see if our movement input is in the same direction as the probe input, because then, if our regular steering is already telling us to turn more than our collision avoidance is, we'll just keep it. And similar with the probe, only this time we query the contacts from the world based on that little probe, which was what we debugged last time, which is the little red sphere that floats out in front of them, and do a similar thing. You know, if that's no better than what we're already doing, then we'll just keep doing it. So that's all the steering stuff. And then, yeah, we actually steer the player, or not the player, the agent, the burb. We animate it based on movement, and then, yeah, the rest is just regular physics crap. But that's the thing, is you calculate steering, perform the steering, pick which animation to use based on how you're moving. If you're sitting still, then it's idle. If you're moving forward, then you're walking. If you're moving forward really fast, it's flapping and running. And this will be where we calculate eating and so on and so forth. So what we want to do is we want to have sort of a brain that gets updated every frame, and it will use whatever, you know, artificial intelligence logic I end up with to choose what this particular agent is going to do. And right now I'm just going to hard code it to cycle through some things. So let's make a class called brain, for lack of a better word. Oh, not. All right, brain.java. Yes, and this is inside of Mythruna for now. I may actually make this open source if it turns into anything useful, but this is my second attempt, and usually it's my third that is the successful one. So we may end up with one more AI implementation. So we'll make this one have access to the AgentDriver at minimum. So like, I'm just winging it for now. I haven't done much of a design except for that I've implemented something similar already. And so the idea again is if you're lost and you don't know what to do, you know, you break things down to first principles, which is what we kind of did before. We know we're going to need some things, and right now I know I'm going to need some steering behaviors. And so I'm going to write, I don't know what my AI is going to look at. I don't know if I'm going to use you know, behavior trees, you know, goal-oriented action planning, state machines, probably some combination of all that. I don't know exactly what it's going to look like, but I do know I'm going to need steering behaviors. And so I'm going to do like the minimum amount of connections here just to get some steering behaviors working, so I can test different ones. And then, you know, from there, I will learn things, right? I will learn, what do we pass on this one? You know, I will learn what dependencies we have between the objects, what needs to communicate with what. Like, I already know that back on the AgentDriver, I'm going to have to set what steering I'm going to use. I might have to set, you know, what animation I want to be playing or what animation set I want to be using. And so we'll just keep track of that. Let's see, how did I define the steering over here? Because we'll really keep the steering over there, and we'll just swap it in. So we've got who sets it? It's set right, yeah, right here. So we're going to have a couple different, yeah, we'll have a constant. So let's do this. We'll start off, what did I call them? Steering primitive, yeah, so steering primitive. Oops. What do they need? Nothing. Well, they might actually. So we'll just steering. We'll just call it steering array for now. And in here, we'll hard code this stuff. Steering array equals steering. Can't type tonight. So we'll put, for the first steering, we just want it to stand still. So constant 0, 0. It's not going to do anything, it's just going to sit there. And then we use our regular wander steering as the next one. And those will be the two for right now. And so we'll keep track of the current one. Index 0, private. long next time equals 0. We'll call this next steering 0. So then when we exceed the time, we'll go there. Okay, so if frame time is greater than next time, then we need to set the steering on the agent, which we have not provided a mechanism for doing yet. Public void set steering. Steering primitive steering. So we already know, see, there's some kind of method we needed to pass steering back to the agent. And so as we think about this, we're building sort of the interface between what does the brain need to talk to the agent. And as we go, we may say, no, that's dumb. You know, we need to consolidate some things, or we're going to be passing things together, et cetera, et cetera. And then we'll be able to turn this into interfaces and maybe formalize it and so on. And so we'll say agent set steering to steering array next steering. Okay, and then we'll prepare for next time, which is next steering equals next steering plus 1 percent steering array dot length. All right, and then next time frame next time. Well, you know what? Actually, it's so much easier to deal with seconds, and so we'll keep track of our own time since we started. So time plus equals step. Time is greater than next time. First time through it will be. And we'll do all these things, and the next time is going to be time plus 5 seconds. Yeah, 5 seconds will be painfully long enough that we'll see that something's actually happening. Okay, so that should be all we need there, but we will have to make a brain over here. I have a feeling that a lot of these things like probe and stuff are going to end up in the brain. Even steering will probably make the brain a steering primitive. Anyway, whatever. There's all kinds of stuff we could end up doing. And so here, brain equals new brain. Actually, we could set this. We could do this in the constructor. Yeah, we've overloaded agent a few times here, I think. Yeah, ADIE. Okay, so we're good. And then in update, we want to have calculated our actual velocity, and before we do any movement stuff, we'll call brain update frame time step. Okay, so after we know we've got our actual velocity and we've done whatever, we know we're on the ground or not, because in calculate collision data we checked our ground contacts and figured out how many ground contacts we have and so on. Oh, and we know what we're contacting, and so we can calculate ground velocity. Yeah, that's the big deal, because the AI might need to know that, right, whether we're moving or not. So, and then the brain will do its thing and update steering, and then steering will do its thing. And so for 5 seconds we'll stand still, for 5 seconds we'll random wander, and just keep cycling through that. And assuming I haven't written any bugs in, so we'll see. We're making good time though. It's only 9:20, so we might actually get to implement some steering behaviors. Woo! Yeah, if I finish early tonight, I'll talk about maps a little bit and fractals, because that's in some of the open source code. All right, now I gotta do this because Oops, a burb. Oh, look, he's just standing there. Is he doing his idle? No, he's not doing idle, though. Oh, there he's going. He's not doing any animation. Oh, he's standing again. 1001, 1002, 1003, 1004, 1005. He stops. Okay, so something we did broke animation. Because that was working before. So let's make sure that that's true. By commenting this out. So if we comment that out, we should have the old behavior. Always verify your assumptions, kids. Folks. Because sometimes you go down a whole path saying, oh, but maybe it wasn't working before either and I had broken something earlier. I should have placed a bird when we were... Should have placed a Gafen while we were talking before about warping and stuff. No, animation's not working. Oh, even Fade's not animating. Whoops. Except for... Oh. Oh yeah, she's twisted weird. Like I could... If I had my sword selected, then I could drag it. Oh no, it's only... Animation's only working on the server. So I broke character animation state. I removed some hacked code. But that shouldn't have affected the Gafen. Ah, crap. So something I did to character animation state or the rig stuff. I'm trying to decide if I spend a few minutes figuring this out. What did I change? Character animation state. I didn't change anything over here really. Let's check the code. Whoops. It's close enough. First of all, so we'll open both these. Mythruna, what was the last commit? I removed a log. So that might have broken that. I wasn't sure if that was going to work, and because I had the debug stuff up, the actual see, this is in model view state. Because I had the debug orbs up, I saw those because those so let's comment out that and see if animations are at least working again. Fade's drag and stuff will stop working, but I was hoping I could get away with just moving the animation control over, but I think that that's not going to work, and I would need to sort out why. I thought I had a hacky solution to my problem, but apparently I don't. I don't want to spend too much time messing with it. Okay, she animated? Yep, she's animated again. So yeah, that's what it is. That animation control I copied over is a bad one. It won't let me do that. I'd have to do some additional fix-up. And so if we place the burb now, yeah, so he's walking around. Okay, so let's put a pin in that. That was what I did Saturday and Sunday, I guess, was... Or no, I must have just done that yesterday, day before, whatever. That's not what we're here to play with today. So let's go back and put our brain back in place. And while we're there, let's change one other thing. I want to change the rig animation to have a default animation. Private string default action idle. Okay, normally that'll be our default action. Set default, set default action string action. I get myself in trouble by not using the same. Okay, so we'll use that because I eventually want to change the idle animation to be eating. That's not the real way. Idle should be the default animation, the default action always. But I'm not sure I've got layering working right, and rather than mess with that, I'm just going to punt on that. I also have to set the animation configuration, which I think I do in here, so that we actually have the eat as one of the... So, okay, so maybe this is worth talking about. Mythruna, and indeed a lot of my stuff, uses one of my open source packages called SimEthereal, and it's a object syncing library using UDP. Well, now it does because there was a bug and it wasn't before. And so, you know, it has like shared physics spaces, and it automatically handles making sure the objects get synced so that we all see the same things, and it's high performance, real time crap, blah 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 blah. It also supports parent and child objects. So where's my whiteboard when I need it? Is that the one? Yeah, that's fine, whatever. Oops. So when Fade's running around, you know, her backpack is attached to her sword is attached to her hand. Those are child objects in the physics space, you know, in the network space, so that the objects get networked can have, you know, children attached to them, and the networking automatically keeps track of the difference between, you know, their offsets. And so if they move relative to their parent, you know, that information gets sent in. When the parent moves, that information gets sent in. The cool part about this is the way the networking library works is if there is no movement for a particular object, it just sends like 1 bit. So it's extremely compact information. If there is movement, then it, you know, it sends a bit plus, you know, the information. And so what I've done, you know, so we've got Fade, and she's got you know, her backpack, that's an object. She's got whatever she's holding in her hand, that's an object. But I've created these fake objects which represent sort of what animation she should be playing. And so these aren't ever represented as physical objects, but they'll tell you, like in here, it will tell you which of these it should be playing and how fast. So like the position, like the X of XYZ, you know, of the position might tell you how fast that animation should be playing, and the Y will tell you which of these animations should be playing, and so on. And there's multiple layers that can be there, but I'm not sure the layer stuff is working right, so I'm just going to put eat in with the idle walk run as one of the animations. The chickens or the Gayfin already have an eat, and so this fake object is a way of like tricking it. It's going to just do the same children, so the networking will send all that stuff, and the animation changes and the animation speed and stuff will all be synced with all the other movement that's going on, so they're all in sync. It's just a trick, and it's kind of a cool trick. So anyway, So I'll add, go ahead and close that. So go ahead and add eat there so we can use eat. If we didn't have that, something would error out because it doesn't know. It only knew idle walk run. So anyway, and it's important that these kind of be in order because these are supposed to be continuous. What happens is that we send a value between 0 and 1 that represents each of these things. And because of the way positions are tweened on the client, one frame it might have been 0, and the next frame it might have been 4 or 1 rather, and it's got to real quickly transition between all of these. And so it's important that these kind of be in like a logical order. Otherwise you'll get weird transitions as it moves from one to the other, as it shifts quickly through. I don't know, that's hard to describe, but just trust me. And so when this is good, we did this, so we have a different default. For the brain, I want to, when it's the standing still one for now, if, so if next steering equals 0. So if it's the first one, agent set default action eat. Again, this is temporary because we're kind of hack wiring some things here, because normally probably the brain would have already been controlling the rig animator default action, which is why it's weird that we have to pass this all the way through. What is it called? Animator down here at the bottom. Rig animator, yeah, so where'd I go? Right here. So that should make him stop and eat, in addition to the other animation we got going on. I think I had a brief view at one point. Alright, so continuing right along. So this should get us to the point where we can start developing some different behaviors with animation, because that's always more fun. Alright, I should still be, there it goes. Oh, look, it's stopping eating. And then it wanders around. Look at him go. Bop, 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 bop. And he waddled away, waddle, waddle, till the very next day. The gate from walked up to the lemonade stand. Yep, look at him go. All right. So now we can implement some different behaviors. I think what I want is, I want him to keep track of where he was first created and then go back there, head back in that direction after some period of time. So he'll stand and eat for 5 seconds. He'll wander for 5 seconds. Or maybe we'll make those longer. Eat for 5 seconds, wander for 10 seconds kind of thing. So yeah, well, let's make a slightly more advanced AI, right? We want to be able to set different times. So what we will do is we will say double time. What do we want? Duration. Durations. So we will set... This is not how you construct AI. Again, we're just putting some hard-coded things together. So he'll eat for 5 seconds, wander for, let's say, 15 seconds, and do whatever the next thing is for however long we want that to happen. But the next steering behavior I want to implement is the we don't want him to eat. We don't want him to eat every time he stops. So we'll set idle back. Okay. So now we have to. Now we will implement an arrive behavior. So I want to be able to say Yeah, so we make them walk. The steering behaviors, steering primitives I have set up to be, sort of always returning 0 to 1 for a speed, and then I can scale that down to what the chicken or the Gaphin speed is. So that's what the scale speed does. AgentDriver, when we create the brain, we create it too soon because I'm going to want to grab some things about the brain, about the agent. Yeah, so we'll create it down here because then we can start asking questions. We can ask for location, for example. So we will arrive at agent location. And let's see let's look up steering primitives. Okay, so wander takes the distance, radius, rate. Yeah, we don't care about that. We want to be able to specify a location and sort of how close we consider being close enough. Okay, so that'll be our new one, and we'll do that for 5 seconds just to be sure we wander for a while and then wander back. Oops. Okay, so we have not implemented that yet. We are going to implement that right now. And so we want I call it arrive vec3d location distance. So return new arrive distance, and we need to know, like, random wander didn't need to know the agent, but we do actually. We need to know what we're dealing with, so we'll have to go back and put that in to our brain. Can't just arrive, we have to know the agent. So that agent will wander towards there. Yeah, make it a straight beeline, maybe faster than, in fact we could make it, oh, I forgot to include the scale. So we could actually make him go faster, so not 5.0.5. He would go really fast. So he'll wander at quarter speed and run as fast as he can. Well, half speed, half of his max speed. Actually, I think those are meters per second. They're not half of max speed. So like wanders at a 0.25 meters per second, and he'll head back home, quote unquote, at 0.5. So that should work there. We've got this thing. Now we need it. Just all we have to do is implement it. Ha ha ha. I'll reorder these later, but it's going to be convenient to have it. It's going to be convenient to have it right up here near the top. All right. AgentDriver, vec3d target, and double distance squared. Agent equals agent. Oh no. Target location, and this dot distance squared equals distance times distance. And that's just so we don't have to calculate real distances with square roots. Okay, so then for this we come here and we figure out where the so we know the direction, or we can figure out the direction. So we need to know which way is the burb facing, which is agent dot alt vec3d unit z. That's what direction he's facing. Where is he now? Call it get location or get position. Get location. I flip back and forth on that and it drives me nuts. Okay, and so then we are trying to get to, oh, you know what, we're going to need left to, those unit x, because in whatever handed coordinate system we're in, you know, z points out our nose and x points out our left ear. So we're target, subtract location. So that's the direction we want to go. Dir is the direction we are actually going. And of course, if relative, if the square distance of relative is already less than distance squared, then we're close enough and we can just say, nah, that's okay. We don't need to, oops, false. We don't need to do anything else. We're good. Otherwise, we need to figure out which direction to turn. And so that's going to be the dot product of left and relative. Dot. Although we really want to normalize. Yeah, so this is not efficient, right? I actually have calculated the, this is length squared, by the way. Calculated the length there anyway. I could have just used it anyway, whatever. So we'll normalize it and get it so we have a direction to steer. And so then, like if we see how we've done some things down here, like for the constant, for wander, we did a similar thing. We figured out which way to calculate a turn, and that's right. We also should see if it's behind us, because that's another point. So let's do forward dir dot. Okay, so here what we're going to do is relative normalize map 3 target dir equals relative dot normalize local. Oh, not, just normalize. Okay, just in case we need relative for some of those. So it's dir dot target dir direction to the target, and we can use that here. Okay, so forward will be positive if we're heading towards the target, and negative if we're going away from the target. And so if turn is not equal to 0, so if forward is less than 0, then if turn is not equal to 0, then turn equals math signum turn. So what this does is, if we were already going to be going a little bit left or a little bit right, then we will, but if the object is behind us, we will maximize that. So if we were negative, we go full -1. If we were positive, we go full +1. If we're 0, then it's behind us. We just need to pick an arbitrary direction. So we'll just turn left. I think it's left. Should be based on the dot product here. And so that's good enough. And otherwise, yeah, that's good. We may want to, yeah, so here's a place where I wanted the distance. Relative dot length. And so then I can mult 1 over distance. Yeah, so anyway, because if our distance is starting to get short, I could slow us down. But for now, we'll just go full speed and target. How do we do this? Move, set. Move X is the turn, move Z is, yeah, so see, move X is how fast we're turning, and target move Z could be, we could slow it down if we're getting really close. So say we're getting within a meter. If distance is less than 1, or oh, you know what, I'm reusing the word distance, target distance, which is bad. Let's call this, oh, that's distance squared anyway, so I'm actually good. Target distance, target distance. Okay, so yeah. So let's say we're within, just really there should be like probably another parameter, but we'll just say if the target distance is less than 2 times, yeah. Well, I get a lot more done when I'm not answering questions, haha. So we have one viewer, I guess, and anyway. If you're on and want to say something, so just drop a message in the chat. So 2 times distance. So if we're getting close, then we'll slow down. Otherwise, we'll just set movement to 1. Go forward by 1. Well, you know what else we could do is probably if the thing is behind us, we want to slow our speed down as well. Target move.z, slow down if it's behind us, so we turn more towards it. Okay, so if we're getting close, then target move.z, yeah, we'll just slow down. We won't. Normally I'd scale, but I've coded too many things without trying it yet, so let's see if we even compile and then see what I've missed. Yeah, so target subtract. Do I not have a subtract method on Vec3D? Oh, it's agent movement input. Too many targets. Too many reused words. That's why it's good to stop and think about how you name things. Alright, so 99, we didn't return true. Okay, should work now. How much time did I give it? Oh yeah, that's on the other, that's in the other class. I think 5 seconds, right? Yeah. So she eat for 5 seconds, walk for 15 seconds, head back to its starting position for 5 seconds. You know, wherever it initialized this run. Alright. Is the other one still walking around? Yep. Okay, so he's eating. Oh, he's not. He's idling. Okay. Now he's eating. Alright. Now he walks. For 15 seconds. Oh, that was short. Now he's sitting where he is. Now he eats. Okay, so something's wrong. 2002, 2003, 2004, 2005. Oh, I know what's wrong. So what I didn't do was actually use those times. You know, I set durations, but I didn't actually use the durations. I'm constantly adding. So next time equals durations. Whoops. Next steering. Okay, so we set up for the steering. Okay. But I also think I'm going to want to debug the arrival so that we see what it's doing. You know, a lot of people believe you should run all your code through a debugger. I'm not one of those people, but it is useful to look at what's going on, right? So let's see, we've got, where are we right now? Look, it's our dir. Where are we headed? Target. Okay, let's just see what we got going on there. And work from there. Oh, I've only got 8 minutes left, so hopefully we can get arrive working at least. Thing is, like, running in the debugger can be tricky, especially in client-server apps and logging, where it's always there for you. It's always your friend. All right, so is the bird still around, or he disappeared, right? So I get to place a new one, which is good. Just waiting for all that logging to go spewing by. That was weird. Okay, so he eats for 5 seconds. 2, 3, 4. Okay. 2003. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now he's not doing anything. So why is that? Let's check it out. Let's check our logging. Oh, I know why. So if we grab one of these, grab one of these lines so we can look at it. So our location is here, and our target is also in that exact same location. And the reason is because we didn't clone the vector. So whatever we do in here, we will maybe assume that, well, maybe the caller wants it to move, so we will do the cloning here. So arrive can't know that it should clone it. We may have wanted to update it live, and actually that could be a pursue. Anyway, all right, so now it should work. And so wherever we place him, wherever he starts, will be his quote-unquote home, because the AI isn't smart enough to know where its real home is, and I can't easily place that kind of stuff right now. Could be a special object. Yeah, me too. Like, for years with C, like, we got to the point where we get a core dump, and that's what we use the debugger for, to look at the core dump. Okay, so he's doing his thing, walking, wander. For 15 seconds, he's going to get stuck in a corner. Okay, and eventually he walks slowly back to where he was, and now he eats. Okay, wanders around again. Of course, he's already stuck in this little area, so he's not going to get very far from his starting location. All right, let's do a different bird so we can actually, let's get rid of him. Let's delete that bird. Okay, so let's put one over here. Yeah. Okay, so he eats for 5 seconds, wanders around a little bit. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In a second, yeah, he heads right back to where he was. Eats. And then goes wandering on again. And we can actually chase him a little bit. Make him wander farther off. So maybe he doesn't quite reach his goal again. Alright. It's going to get really dark on YouTube if I don't... Yep, look how fast he heads back to his spot. And then he slows down when he gets there. Stops and eats. Okay. Arrive is working. Yeah, lots of logging. The nice thing is... And eventually... I'll have console commands to set log level for different things, right? And then even when you guys are playing the game and you're like, I'm having this bug, I could even like tell you how to set the log level so we could get more information. Hey, look at him fly back. He goes back home. Okay, so the arrive behavior is working. And that's really like the minimum of what I want. You can see how like arrive and pursue. What I wanted to have is if we have a bunch of these guys placed around, the pursue was going to be working on, they would query the world to find out what Gafen were around them, and then pick one to, they would pick one to try to follow. And so you might end up with like a chain of them. And eventually, like for testing, I'll have it randomly pick times so that they're a little less predictable. Because like all these guys are going to be eating at the same time. Oh, what's he doing? They're bumping into each other, so they were interrupting their eat animations. That's kind of funny. There's whenever you get these sort of emergent complexity for stuff like this, there's an endless tweaking. But so that's why you gotta like concentrate on your first principles, your primitives, get your steering primitives working right. Look at all those guys; they're eating all in unison, and then they walk around, and so. Yeah. So these guys are working. So let's real quickly talk about maps, because this is sort of the minimum I wanted to get done today, and we don't have time for the pursue behavior and querying the things. And I have my entire next week off from work, so I'm trying to get done some of the big pieces. One of the big pieces I want to play with is AI, and I may actually, if there's enough interest, and you guys can comment on the YouTube video if you want, or in the Discord. If there's enough interest, I will do multiple live streams over the week with sort of the things I'm working on for AI, or the maps. So let's talk about that real quick. Let's go ahead and exit the game. So sometime back, I wrote, so Moss, you can see the directory here, Moss, that's the Mythruna open source software. This is the part of the open source software. If you guys are patrons and are developers, all you have to do is ask for access and you get early access to this. But it'll eventually be open source, hopefully 6 months from now, 7 months, something like that. But I wrote this tool for messing with the fractals. And so I'm going to show you at a high level what the current fractal looks like in this little developer tool. Originally, when I wrote this, I thought, well, I'll have like some kind of node system for composing fractals, but the fractals tend to be built upside down, and it's not 100% clear how a node system should work for that, and so I've opted for just doing it in scripts for now, because I don't need to develop a node editor to write Mythruna. It's a nice thing to have, but I don't need to develop. So this is the fractal we're using right now, and you can see maybe, I don't know if you guys can see this, but to me it's certainly random, but it's regularly random. Like you end up with similar style clumps, similar style stuff, and if you zoom in you can kind of see waves of hills and stuff, and that's really nice for testing. This tool is pretty cool, by the way. And this one, so it plotted out some rivers. That's really why it took so long to render this, because it calculated some rivers. And it has code in here to calculate where cities and things should be. But so this is sort of the basic, and you can zoom in like these big squares are what should be like a day's travel, the big hexagons, and this is sort of the scale of it all, right? If you go in, that's the ship with a bunch of buildings. So this is the sort of real scale of the terrain, and in this you can actually see quite a bit farther. I need to add a sky sphere that you can toggle on and off because like if I zoom back out up here, you can really only, in the real game, you can only see for, you know, maybe 8 of these hexagons. 1, 2, so 8 of the little ones. These are like 1024, so that's a kilometer. 1, 2, 3, 4, 5, 6, 7, 8. So roughly right around here is what you could see, you know, in the game. That's the far clip. But in here you can actually see considerably farther, right? And that's not realistic. I'd like to have an option like a toggle over here to say turn on skybox so I can see what the terrain actually looks like. Anyway, this is the fractal that's being used in Mythruna right now. And I have another fractal that I'll show you. It's the one so this one I think it's boring. It's cool, don't get me wrong, right? It's cool. But maybe when you've looked at these for a long time, you start to see sort of a sameness to it all. And so I actually have a different fractal that I'm working on, and this tool is cool because I can edit them on the fly, and it will so like if I let my fractal come into play, of course it's not going to replot the rivers, but it'll replot the terrain at least. And this one will still take some tweaking too, but oh yes, it's got to render all those different layers. And no progress bar. You know, this is very primitive tool. Come on, finish. I guess it did finish that. No? Yes, it's still got to render all this stuff again. You know what? It's not going to replot the rivers anyway, so I'm just going to restart the tool with this in effect. That way you get like a clean run. Yeah, I have like this map of here for comparison. This would be this whole area here is, you know, 16 by 16 kilometers roughly. It's like 15 and a half. Oops. And so come on. Yeah. So that would be one of these squares, roughly, is one of these maps. It's like the Perlin noise is underneath there, right? I also, in this case, I also have some cellular noise. You'll see, like, we get these cool areas of the world where you get these cool, you know, cracked, high mesa kind of things, plateaus. But this, so it's several fractals layered together, and if anybody wants, if they request it, I can make a video where I can talk about how this stuff was built up from, you know, regular fractals that are based on Perlin noise, you know, with different octaves and frequency and stuff. So that would have been the spawn point. It used to be when this map was generated that the spawn point was down here, and it's a way cooler place to start. But there's this place where there's this river that comes off this cliff, which I think is kind of cool. It'll pull in some detail here. So this one you actually get like these sheer cliffs and things because it has different fractals that come in, similar to the fractals that, you know, clip out these rocky places. Yeah, okay. And so you can, you know, so sometimes it carves out like these kind of places too. The thing is, I haven't actually looked at what this looks like in the game, and because I don't have a skybox, I can't really see how far I can see. But I can say I've messed around with this fractal a lot as far as plotting roads and cities and towns. I think that stuff's commented out. Yeah, so there's like settlements, roads, balancer, display settlements. Let's see if I turn all that on. It takes a long time to generate though. So we'll watch the logs here for a second while this comes in. Yeah, me too. I like it because I get to play my own game, right? I get to run around and discover things. And I spent a lot of time messing with the algorithms of this particular map and putting settlements down, and then letting my imagination run. Oh, there's where the algorithm would have to build a bridge, and here's where the dwarves would live, and stuff like that. Yeah, so this is going to plot out bodies of water, roads. So it plots out settlements based on some algorithms that I have that say like there should be interesting things within so many meters and so much walking distance and so on and so forth. So it figures out where the optimal places for towns should be and what kind of towns they'll be, whether they have like farming there or lots of trees, or they're coastal towns, and then plots out. Yeah, see, it's looking cool. Check at that, like that. So those are all the towns, the cities and towns and stuff that it would plot out, along with the roads. The brown are sort of the rough roads that join the world together, and then these blue would be shipping routes between the different cities. And so you get some of these that have and again, all this is still kind of prototype, right? I need to make it fast, but you get these little spiky things that I don't remember what all they mean, but they have to do with what that town would be good at, like different color coded things. Like this town over here probably developed because of all the cliffs, which means there's probably mines there. These probably, well, fishing and seaports and things. It knows when there's shallows and it's probably good fishing, stuff like that. This usually there would have been a spawn point here, and so one of these towns would be important because it would be within a walking distance of the spawn. These little yellow things, as I recall, they indicate where ports could actually be. Like, so the town might be pretty large and there'd be different places for ships to dock. But I had so much fun playing with this and wandering around and looking at how it generated the roads for different places. And so even like you get this little sea route to this little island out here in the middle of nowhere, because there must have been something about this that made it desirable. And so, given, this is, again, this whole map right here, 16 kilometers, is like one of these tiles. So already it's hard to walk around here. So it's, oh crap, stop, go away. So already, like if you walked here, it takes a long time. Like 3 of these squares is usually like a day cycle travel, if you just walked casually. Anyway, it's kind of cool. You get this little town that develops here with nobody connecting it. But anyway, so the key will be building in something where it can generate the cities for your starting tile, so you kind of know when I start here, that it knows the stuff around me, so that it can generate the immediately surrounding area that it normally has to do. But also in the background, it's got to start figuring out these next big tiles and how the roads connect and how the sea lanes connect. And I look at this stuff, it makes my imagination go, because you've got this seaside town on a cliff, right? And so there would be, it says there should be some ports down here in this trench, which would be kind of cool. And so, there'd be, ocean or sea that comes in there, and some ports, and maybe some kind of ramps and stuff. Again, the algorithms would have to get more advanced because, it would have to have some way to get down to there. And it could be that initially no towns generate there because it just can't figure out how to do it. But this was sort of the pie in the sky, just working out, can I place towns by resources? Can I connect them by roads, based on the terrain? And indeed I can, and have a bunch of rivers and things that plot around. So it'll be fun. I think there's probably not enough rivers, but it's hard because if I add too many more rivers, then it starts plotting them here through what would amount to dry lands, and there probably wouldn't be any rivers in here, but probably more rivers out here than there are. So some things will have to be tweaked, and that's kind of the endless tweaking that has to happen with stuff like this. Anyway, I've had a lot of fun making this. I look forward to having some of this stuff in the game, and so I'd like to get to at least placing where the towns would be and plotting the roads, because then I can work out where the bridges are, where the tunnels are, and maybe drop some seaports on the coastlines when they're easy. All right, I think I'm going to wrap it up there. We got some stuff done. I found a bug in my animation stuff that I got to go back and fix tonight. And so this week I'll be working on AI and maps, I think, or fractals, because I really want to get this fractal in the world and see what it looks like. Maybe tweak it a little more, and I'll think about what kind of content I want to put together for a live stream about fractals. Maybe I won't wait till Friday. Maybe I'll do that one of the live streams next week if I do some midweek live streams. So thanks everyone who joined me live here, and thanks for talking in the chat. And I think that is where I'm going to wrap it up. If you guys have any questions, ask them real quick. Otherwise, ask them in the video chat, or like, comment, subscribe, all that stuff. It helps the algorithm, feed the algorithm. And if you're on the Discord, you can ask questions there too. All right, thanks guys. Thanks. Oops. Crap. Thanks again to my patrons. And I will see you guys next time.